Conventional versus addressable systems. There are two types of fire alarm system based on the type of technology. We are talking about conventional systems and addressable systems. We can also include a third type known as hybrid system, which are nothing more than a combination of an addressable panel using conventional devices. Conventional fire alarm systems are the one whose initiation device, like detectors, pull stations, and modules, are grouped by zones. Each zone can contain up to 30 devices depending on the characteristics of the devices. At the end of each zone is placed a resistor known as the end-of-line resistor. The output devices are grouped in the panel output known as NAC, which stands for Notification Appliance Circuit, and is where the panel sends enough voltage to sound the horns and turn on strobes. In this example, we have a conventional two-zone panel. Let's imagine that the person has spot fire and has decided to activate the pull station number 2. This pull station belongs to zone 2 of our fire alarm panel. The panel activates automatically the horns and strobe. The panel simultaneously sends an audible and visible notification through its display telling us that an alarm was triggered in zone 2. With these conventional panels, we cannot know exactly which of the pull stations in zone 2 was activated, so we must physically verify where the fire was spotted. Now, let's imagine that we have a problem in zone 1. In this case, somebody cut the cable between detectors 4 and 5. The panel automatically sends us a warning that is known as trouble in zone number 1. As in the previous example, we do not know in which point the cut occurred, so we will have to do a general check of the entire zone. Let's talk about addressable systems. Unlike conventional systems, instead of grouping the initiation device by zones, they are grouped in loops known as SLC, Signaling Line Circuit, where each device is named on the panel as a point. The SLC or loop provides power, communication, and supervision of the devices. Each loop allows up to 200 or more points to be connected. This may vary depending on the manufacturer. This amount is divided equally in two. 100 points for the detectors and 100 points for the modules. Modules include pull station, supervision modules, control modules, and output modules, known as relay modules. The addressable panel can support up to 10 loops or SLC. This means that up to 2000 points can be grouped in a single panel. If we add the addressable system allow connection between panels of the same family, each panel becoming nodes in this type of connection, a main panel receives the signal from the secondary panels. With this type of configuration, our availability to grow is even greater. Based on the image, if the main panel is in building A and we have other secondary panels in the adjoining buildings B, C, and D, any alarm, problem, or supervision coming from the panels in building B, C, and D will be received in the panel located in building A, displaying on the screen the address of the device and the location. Now, for notification, the addressable panel have NACs also, as the conventional panels. But we can also connect horns, strobes, and speakers through addressable control modules that allow us to divide the notification loop into floors or sections. For example, if in a building the firefighter department requires that in our design any alarm only activates the horns of the corresponding floor where the signal came from, the selection of this type of control module is what we need to achieve it. Besides, there is no limit in terms of growth. it is only necessary to be careful with the voltage drops, for which we will need more power supplies. In the last section of this course, we will make calculation corresponding to the voltage drops. Let's make a simulation of how the addressable fire alarm system behave in the different types of events, which are alarm, trouble, and supervision. If you can observe, each of the devices in this system has an identification number or address, which is physically assigned to the device, and then the main panel by programming recognize this address. After recognizing these devices, it is possible through the panel to assign names to each device, which facilitates its location. Now, let's imagine that there is a fire in the room where we have the detector with code 6. Automatically, our panel turns on and displays a signal indicating that there is an alarm for point number 6, which is smoke detector number 6 in the room. At this same time, the horns with strobe are activated to warn the personnel. By design, it was established that the pressurization system, which we will discuss later, have to turn on every time an alarm occurs. So in the case, the relay module, which we have already programmed, must turn on our pressurization system. This relay module has the address number 3. Now, we have encountered a problem that we have a damage in detector, which is the detector with address 1 located in the warehouse. Automatically, our panel displays a signal of a trouble from point number 1. In the case of troubles, they should not activate the horns with strobes. Finally, the maintenance personnel have decided to close a valve, as they are performing maintenance of the sprinkle system, so they need to remove the water from that section. Closing the valve does not activate an alarm, so it does not turn on our horns with strobe, but it does turn on a signal on the main panel corresponding to supervision, which sends a message that we have a supervision on point 4, which is a module that supervises the valve that is located on level 1.